In this tutorial, we're going to use the definition to find the Laplace transform of f of t, which is equals to exponent of 2t. When we are given a function f of t, which is defined for t greater than or equals to 0, the Laplace transform of f of t is f of s is equals to the integral from 0 to infinity of exponent of minus st times f of t dt. But in this case, we are given our f of t there is exponent of 2t. We substitute it into the formula there, and we get the integral from 0 to infinity of exponent of minus st times exponent of 2t dt. But where we have exponents there, we can simplify that part using laws of exponents, and we'll get exponent of minus st plus 2t. And then go on and factor out the t there, and we'll get the integral from 0 to infinity of exponent of minus s minus 2 times t dt. At this stage, we can now integrate that, and when we integrate, what we get is exponent of minus s minus 2 multiplied by t divided by minus s minus 2, and then we put the limits 0 to infinity. And when we put the limits there, for the upper limit, we'll write it as the limit as t approaches infinity of exponent of minus s minus 2 times t divided by minus s minus 2, then minus exponent of minus s minus 2 times 0 divided by minus s minus 2. But we can look at that limit there, the one where we have the limit as t approaches infinity. That limit can only converge when s minus 2 is greater than 0. And this is so because we said our t there is greater than or equals to 0. So for that exponent to converge, s minus 2 should be greater than 0. And if s minus 2 is greater than 0, we would have s greater than 2. So if s is greater than 2, that limit will converge to 0. So if we substitute into that expression on the left there, our limit there is a 0. And then where we have the lower limit, we are substituting a 0 there. So it will be exponent of 0. And where we have exponent of 0, we put a 1. So that expression becomes 0 minus 1 divided by minus s minus 2. And that is valid only when s is greater than 2. Just because we said that the limit will converge only when s is greater than 2. And we can then go on and simplify that, the minus multiplied by the minus sign there, and we get 1 over s minus 2. So what we are having there is the Laplace transform of exponent of 2t is 1 divided by s minus 2. And it's only valid when s is greater than 2.